Okay, so this is Shawn Hawkins' video about pretty much every single one of my videos, although he skips bits when, you know, it comes to the proof of the coins and shit. Anyway, yeah. So, let's just go through some of this and correct him on his mistakes and his misconceptions and his lies, as well as calling me a liar and assuming wrong as usual, as people do. You know, when they could just ask you. So yeah, let's go.
Yeah, I sent this video of the levitating balloon to a commenter, and they was like, "Oh, you sent me an Eric Dubai video." I don't care who it is. I don't know who that is.
So you're a flat earther and you don't know who Eric Dubay is. I find that really hard to believe.
Well, first of all, I came to flat Earth not believing in gravity because obviously, you know, once I heard about bendy space-time, it was almost a ridiculous concept to the point where you couldn't believe in gravity. So then I thought, without gravity, you can't be stuck upside down to a ball. Then obviously found flat Earth videos and things, and, you know, basically this is my first ever video. And for me, it was like finding out a reason why things fall. And I found out that obviously without gravity, you need another reason why things fall. So then I found out that, you know, more dense down, less dense up. And then I decided to search, you know, is gravity just density? And then I came across Eric Dubay's video. Of course, if you search that now, it don't come up. It used to come up. So I used to just search gravity is just density. And I'm thinking, like, no, somebody else had the same ideas and things. And it used to be the top one. But because of the censorship, now it's no longer the top one. So now I've had to actually go through his video to find the video. I nearly swore then. To find the video to, prove that I'm not lying. So 8 months ago. So I just thought I figured out why things fall and it's not gravity, it's density. I then think, shall I upload a video explaining this? Thought I would check if somebody else had the same idea. Turns out you did. So this is the very first time that I ever came across Eric Dubay, and that was for me searching that, you know, gravity is just density. And that's when I came across Eric Dubay. So, again, I'm sorry that you don't believe me, but that is what happened. That's when I subscribed to Eric Dubay, and that was 8 months ago. Roughly when my video came out, because that's when I found out, you know, that gravity is just density. And although I felt like he explained it and the levitating balloon was awesome and that, it's just I felt like maybe, you know, I could explain it not better, but in a different way. I felt like maybe there was some things that he missed out and things. So I thought I'd just explain it in my way kind of thing. But, you know, I obviously search gravity is just density thinking, you know, I can't be the only one with that idea because it's so simple. Do you know what I mean? Like, once you get rid of gravity and then you start to think, why do things fall? Obviously, you know, you come up with more dense down, less dense up. Because that's reality. Right. So, back to Shawn Hawkins' video.
So the helium balloon drops. She says it's because the plane is moving up and it's the air is becoming more dense down at the floor of the plane, so it wants to go to the more dense because it's helium.
I think let's just skip some.
We'll check it.
YouTube video. I shoot the football game tonight. Was going to originally upload a video about how.
Or television or whatever you're watching.
No.
Yeah, the television was on because obviously I got 2 kids and I was trying to not wake them up, so I was trying to drain out my voice a bit. I haven't done that since, but, you know, obviously it is distracting and I understand that. But yeah.
I think it's the same lie as, I really don't want to be a flat earther, but I looked at the evidence and I just...
The point is to...
I think it's the same lie as, I really don't want...
Basically, he's trying to say that my Eric Dubay video, you know, not knowing Eric Dubay was a lie. So now he's saying that this is a lie too.
To be a flat earther, but I looked at the evidence and I just couldn't deny it.
Yeah, because it's hard to find evidence of the globe. Like, irrefutable, concrete evidence that it is a globe. And that's the problem. Because there's not irrefutable, concrete evidence, there are flat earthers. Until you provide concrete, irrefutable evidence that somebody's like, yeah, okay, so it has to be a globe, then they're not going to believe the globe, aren't they? Do you know what I mean? It's almost like believing in unicorns. Would you believe a unicorn without irrefutable evidence of a unicorn. Is a picture going to be good enough of a unicorn? Of course it's not. You need irrefutable evidence, and that's what people need of the globe. Irrefutable evidence. You know, literally irrefutable, where there's no other explanation. And then, you know, maybe that could go back to the globe, but it's just hard to find that evidence, even for me. Now, I'm like, I mean, for me, it's like, it depends on the day. Some days I'm more flat earth, some days I'm more globe earth, some days I'm like, I have no idea. And it's like, it's just hard to try and figure it out. And, you know, you're saying that it's basically easy. It's not easy. It is a hard thing to work out, whether it's flat or whether it's a globe. And, you know, it's one of those that it's not as easy as what people think it is. Like, it's like me saying to you about the unicorn, like I says, you know, would you believe in unicorns if I showed you a picture? Of course you wouldn't. So you need to find the evidence for it, basically. So yeah, carry on.
Look at the content. Maybe it's funny. And because
Still, there's no air to be buoyant. There's nothing in there for it to be buoyant against or non-buoyant against.
So now he's talking about, like, obviously a vacuum chamber. So in a vacuum, you know, everything's more dense. So a vacuum is essentially zero density, and everything's more dense than that. So obviously everything's going to fall.
Now, what happens if you put a helium balloon, a rigid balloon that holds helium? You put that in a vacuum chamber. You start sucking the air out. That balloon's going to fall.
Yep.
But yet, the helium is still less dense than the air that's left in it, right?
Wrong. And I'll tell you why. Get a vacuum. You know, measure the mass of the vacuum. The mass of the air inside the vacuum. And divide it by the volume of the vacuum. And find the density. Now, do the same with a balloon. Fill it with helium, fill it with air, I don't care. Fill it with whatever you want. Find the mass of that balloon. Divide it by the volume of that balloon. Find the density. Compare those densities. The vacuum will always be less dense. And the balloon will always be more dense. So, no. The helium balloon is no longer less dense than air in the vacuum, because there's hardly any air in there. When you take the mass of the air that's in it and you divide it by the volume of the vacuum, you will get your density, and you will find out that the density is a lot less than the density of anything else, which is why everything falls. You know what I mean? Like, this isn't hard. You know what I mean? Like, let's say you have 5 molecules of air in there. You're saying just because there's air in there that the helium balloon's more dense. No, you have to do mass divided by volume. So do the mass of the air divided by the volume of the vacuum, and you will find the density. Do the same for the helium balloon. The mass of the mass of the helium balloon divided by the volume. Find the density. You will find out, like I says, that there's a difference, and that the helium balloon will always be more dense than the vacuum. So it will always fall. This isn't complicated stuff.
So it falls. Same way with a balloon full of air. You suck air out, the air in the balloon is not going to rise. It's going to fall. It's going to stay down.
Yeah.
I mean, there's plenty of videos on YouTube to explain this. This is researchable. This is, you can look this up.
Yep.
You can find this yourself.
And you can do the maths to find out that everything's more dense than a vacuum.
So, helium, for
that
example, that rises, and gravity will
sell helium. What is mechanism by which they portion out helium to the public to buy it? You think maybe it's weight? Like if I have a tank that's this tall and I want to buy 100 pounds of helium, because that's how it's sold, by the pound.
it doesn't really matter the amount of mass of helium. It will never be attracted to the Earth. In fact, the more mass of helium, the better if you want to make an object float.
So I'd just like to point that out that I'm talking about in air there. So the more mass of helium in air, the more, mass, the better to making things float. So basically, you want a person to float in air, like, you use helium. If I give you 1 helium balloon, you're not going to float. If I give you a few hundred helium balloons, maybe less, you're going to float. Do you know what I mean? So the more mass of helium, the better if you want to make something float, is what I'm saying, in air. But yeah, obviously he misunderstands this or whatever, so.
So the more helium, the lighter it's going to be?
Is that what I said? I says the more helium, the better if you want to make something float. I never says the more helium, the lighter it's going to be, did I? No. I says common sense, basically. You want to make something float, you attach more helium balloons. More helium makes things float. Do you know what I mean? Like, that's common sense, so stop trying to straw man me.
But, yeah, that's completely wrong.
I never said that, did I?
We sell helium by weight. The more helium in a bottle, the heavier that bottle's going to be.
Yeah, because you got mass in that bottle, do you know what I mean? Helium has mass, do you know what I mean?
You think the bottle itself increases in weight?
No, did I say that?
No, it doesn't. Hey, Wally. Hey, Man O'Brien. Hey, Lolcow. Hey, everybody. Oops.
So it's not levitating. I will.
Watch your mouth, all right?
If you went to school, if you took classes, if you talked to people who are knowledgeable in this stuff instead of just look on YouTube for videos.
I'm sorry, what? Like yourself? Who thinks that, a helium balloon in a vacuum is less dense than the vacuum? Like, I'm pretty sure the majority, if not all the people, would disagree with you there. Maybe I'm wrong, but seems pretty obvious to me. Do mass divided by volume, you get density. Do the mass of a vacuum divided by its volume, do you think that's going to be more than a helium balloon? Seriously?
You probably wouldn't be a flat earther anymore. I mean, it seems like she has somewhat of an open mind.
Yeah, I do.
So.
Do you?
I'll pretty much prove mass doesn't attract mass. Spheres, and maybe they aren't spheres, or at least the Earth isn't just.
Disc from all different was a flat disc. Just showing us like a picture of it. It would be oval if you weren't looking straight on. We never see oval planets.
Okay, so now he's going on about planets and things in space being flat. I never said anything in space is flat, did I? You know what I mean? Did I say planets was flat? No. See, this is like another straw man. Basically, because Earth's flat, everything else has to be flat. No. So basically, why as well that I thought or think that Earth's flat compared to the other planets or whatever up there is because we have life on. We have how many different species on this one planet or this one place, you know what I mean? Whether it is a planet or not is still debatable, at least to me. So we have how many species on this one place, this Earth, whatever this place is, okay? We have how many species? Millions, billions probably of species. Now, do you even find one on any of those other planets? No, you don't. So that to me tells me that Earth's different to, if you have been to those planets, I have sent probes to those planets and they haven't found life. And there's no, evidence or, signals of life or whatever. Then, obviously that shows to me that Earth is special because Earth has all this different life on and yet nothing else does. So maybe Earth was created for life and nothing else was. Do you know what I mean? So just because the Earth's flat does not mean that everything else up there is flat. So basically, it's like it's almost like the snooker ball pool table thing. You put them balls on strings hanging above that table. Does that now mean the table's flat? The table's round because the balls are round? No, the table's flat. You know what I mean? Like, just because what's above you is round doesn't mean that what you're on is round. Straw man.
People ask me, well,
Why? The least dense. You say it wants to go through the least dense atmosphere, or
Nope, I never said that it wants to go to the least dense atmosphere. Why are you putting words in my mouth? It's more dense, so it wants to seek its own density. More dense down, less dense up. It's more dense than the air, so it goes down. It's not less dense, it's more dense, it goes down. Helium balloon is less dense, so it goes up. A remote control is more dense, so it goes down. Simple.
Air. The least dense is above it.
Yeah, which is
So
what
if
it
it
down.
has its choice, see, there's no gravity. There's no gravitational vector downward to give it direction. Just your density.
Yeah,
And it's less dense above it.
yeah,
And increasingly less dense as you go higher.
yeah.
So why isn't that thing floating?
Because it's more dense and more dense goes down.
Away from less dense air. So
Yeah, away from it. Because it's more dense.
there's a video which shows
So it wants to go to the more dense air.
Yes, because it's
That's
more
what
dense.
you're saying.
Yes, because it's more dense.
You're completely defying physics with that.
How?
Or flat earth physics. So you can't go down because it's less dense above it.
And it is more dense.
a balloon going left.
So it wants to go down. Now a balloon is less dense than air, so it wants to go up where the less dense is. The remote is more dense than air, so it wants to go down where more dense is. Like, this isn't hard to understand. Hydrogen, for instance, less dense than air, so it goes up where the less dense is, not down where the more dense is. Now remote control, more dense than air, so where does that go? More dense down. It's more dense, it goes to the more dense. It's not less dense, so it doesn't go to the less dense. It's more dense, so it goes to the more dense. It's not hard. It's not rocket science.
So right, there's actually two that I can link. And so it just
Okay. And you say it gets dense through movement,
Yeah.
right? Her latest video has a video.
So I was talking about the car there. Obviously, I like to skip my own voice because I don't like hearing my own voice, to be honest. But basically, I'm talking about the car. It accelerates forward. The balloon, moves forward because, like, as the car accelerates forward, the most of the dense air goes to the back. So the air is pushed towards the back of the car, so it becomes more dense at the back of the car. So obviously, as helium does, it moves away from the air, the more dense air. So it moves towards where the less dense is. And where is the less dense? Towards the front of the car, because most of the air has been pushed towards the back. So again, relative density.
From NASA or from that physics girl, that perky 40-year-old. Yeah, she's going through a midlife crisis. But they show a helium balloon in a vomit comet in a plane. And this plane is moving forward and at an arc, right? So the helium balloon drops. She says it's because the plane is moving up and the air is becoming more dense down at the floor of the plane. So it wants to go to the more dense because it's helium. So it goes down.
Seriously? Oh my days, you cannot get any more wrong than that. That's not what I'm saying at all. What I'm saying is, you have... How can I even put this? So, with my ball analogy, so you have balls on the floor of a plane, for instance. You accelerate the plane down faster than what the balls are falling. The balls are no longer going to be able to hit the floor because the plane's floor is falling faster than what the balls are falling. So then, the balls end up lagging behind. The balls, in this case, represent the air. The air ends up lagging behind. So therefore, you end up with more dense at the top, less dense at the bottom. Not more dense at the bottom and less dense at the top. You know what I mean? No, that's not what it says. Basically, you end up with more dense air at the top, less dense air at the bottom. Because it can't catch up with the floor of the plane, basically, so it lags behind. So you end up with more dense at the top. What does helium balloons do? They move to the less dense. Where's the less dense? The floor. What did the helium balloon do? Fall towards the floor. Why? Because it's less dense towards the floor. You know what I mean? They can't even get that right. Like, if you're going to tell me, if you're going to talk to me, if you're going to talk about me to people and, like, say what I'm saying or what I ain't saying, at least get what I'm saying correct. Because you're saying the complete opposite to what I'm saying.
But it doesn't move backward. See, this plane is also moving this way, so that more dense air would be at the back of the plane than the front of the plane. It doesn't go backward. It doesn't move forward. It goes down.
We'd have to watch that again, are you talking about free fall or are you talking about just accelerating forward? I'm unsure about what you're even talking about here. I'm talking about when they're in free fall. Not sure what you're talking about with accelerating forwards. Are you talking about the shift? There is a shift. You've seen a shift in it. The helium balloon, I'm going to have to go back and watch. But there was some kind of shift because you've seen the people flying towards the back, which technically should mean the helium should go in the opposite direction. So I'm going to have to rewatch that video again and confirm or deny that. But no, I'm not saying that more dense air down and the helium goes towards the more dense. That's insane. I'm saying the more dense air is above and in the plane and it's in above and then the helium moves the opposite direction to that. Not rocket science.
Depend on density.
There's 2 huge tanks of sulfur hexafluoride and you got 1 of helium. And you're just pouring out this gas, right? You're pouring out this gas into a column, into a big room, real high, big room. And you jump off the top of that room. Is your descent going to be forced left or right? Or are you going to fall straight down?
Huh?
Pouring out this gas. Tanks.
Where would you?
So if there's 2 huge tanks of sulfur hexafluoride and you got 1 of helium, and you're just pouring out this gas, right? You're pouring out this gas into a column, into a big room, real high, big room, and you jump off the top of that room. Is your descent going to be forced left or right, or are you going to fall straight down?
Well, 1, I'm more dense than helium, so I'm going to go down. 2, I can't remember the density of sulfur hexafluoride, as I'm thinking of tungsten hexafluoride, as that's what I originally thought of when, I hadn't heard of I hadn't noticed that, sulfur hexafluoride was, there's different ones, basically. But yeah, sulfur hexafluoride, I'm not sure of the density of, but I'm probably more denser than it. So, no, I'm still going to fall, because if I'm more dense, then I'm going to fall. The only way that I would go left or right is if there was more dense to one side of me than to another. Do you know what I'm saying? It's like the balloon, like I said, in the car and things, when you accelerate, the more dense air goes towards the back because it always accelerates towards the back. So you end up with more dense air at the back, so the balloon goes forward. So basically, you're going to need something more dense than me on one of my sides and possibly underneath me too to, make me at least go up and to the left or up and to the right, rather than just going straight down. But being that I'm more dense than both helium and sulfur hexafluoride, then no, I'm not going to go any other direction than down because I'm more dense and more dense equals down.
Because you've got different densities acting on you, right?
But they're still less dense than me.
Now you're going to fall straight down.
Yeah, exactly. Because I'm more dense.
Helium should float. If you've got more helium put into the bottle than the bottle weighs, it should float. But it doesn't.
Liquid oxygen or
It should float.
What? I'm not sure where you've got that conclusion from. If you want to, repeat that back to me, because I'm not even understand. I'm not sure what you mean. I'm not understanding you. So.
Float, right? Alcohol, just any liquids that have different densities. Water. When you go through a parabola, go through zero gravity or simulated zero gravity, or zero gravity like we have on the ISS, that density tower won't keep separated. It mixes.
You sure about that? Or is that just because you've seen one video where it mixes? Are you sure it mixes? You might want to take another look at that. Because I'll let you in on a little secret. It doesn't always mix. Explain that one. Sometimes it layers. Sometimes it layers out differently. Sometimes it layers out, you know, less dense, more dense, less dense, more dense, or more dense, less dense, more dense, less dense. Sometimes it mixes. But I'll let you try and explain that with gravity. Now, I know people are going to ask me to try and explain that with density. And I will try. I'm not saying I have all the answers, obviously. But the problem is, you're saying it mixes in 0G. You know. But that's not entirely true. I suggest you look up a few more density things. Because that's not entirely true. Sometimes there is layering going on. In an unexpected way. But yeah. I'll let you research that. When you get back to me on your findings.
How does that work?
Well, when that mix, it's just because obviously everything's been, to me, it's because everything's been, like, you know, forced upwards for lack of a better term. And, like, they're all bouncing around, bouncing off each other, you know. They're being accelerated. What do you expect them to be like? Like, seriously, you expect them to still be perfectly layered when there's some other, you know, forces acting on it? Obviously, it's going to act differently when other forces are acting on it. But like I says, it doesn't always mix. Take a look at some other density videos. I'm sure you'll be surprised.
Air touching the things. So how do they know what gases to be denser than or heavier than or whatever? How does it know that? Why doesn't it keep separated by density? Because
sometimes
it's gravity.
No.
You take gravity away, density doesn't know what the hell to do.
You're not taking gravity away. You're introducing an acceleration. You're introducing another force. You're adding another force. If you add another force, it's going to act differently, obviously. It's not going to act the same when you add a force. Do you know what I'm saying? Like, let's say we have something acting one way, and then you add a force onto it. Do you really expect it to act the same way when you're adding a force? No.
If it's more dense in mass in the boat, she's normal.
Then not only the surrounding air, but also the water.
If you do the density of the surrounding liquid times the volume.
It's just an empty cup, basically. No roof on the cup, no ceiling, no seal on the cup. So how does density know to make that heavy boat be less dense than water and air?
If it was less dense than water and air, it would rise through the air. Seriously, man. Oh my days. Okay, so it's like the floating tennis ball that people like to throw at me. Why does it float halfway in, halfway out? Well, it's less dense than water, so it goes up. It's more dense than air, so it goes down. So you've got basically like the air pushing it down and the water pushing it up, for lack of a better term. So it's less dense than the water, so it rises, but it's more dense than air, so it goes down. So it kind of ends up, you know, half in, half out the water. Because it can't float through air because the tennis ball or the glass or whatever you're on about the boat in this specific situation. You know what I mean? It's less dense than water, so it rises. But it's more dense than air, so it falls. But it doesn't fall through the water because it's less dense than water, so it rises. But it doesn't rise through the air because it's more dense than air, so it falls. So you end up with it, you know, floating on top of the water almost. Because you got it going down because it's more dense than air, but up because it's less dense than water.
Because some of that boat is in the air, but it should be lower. It should be at the level of the water.
No, because
it shouldn't be higher than the air that surrounds it. And there shouldn't
but it's more dense than the air, so it falls. I know what you're saying, and that's what you're saying. But then you've got to remember it's less dense than the water, so the water's pushing it up. Now you've got to think which one is more powerful, basically. Is the water more powerful? The density between that and the water, or the density between that and the air? Which one's more... Do you know what I mean? Like, it can't go down any more into water because it's not more dense. So it has to go up. And it can't go up into the air because it's more dense than air, so it has to go down. So you end up with it like bobbing in and out the both kind of thing. You know what I mean? Like, it can't be underneath the water completely submerged because it's less dense. And it can't be completely in air because it's more dense. So then it ends up sitting, you know, on some water and in some air. It's just the way it happens because it's, you know, more dense than air and less dense than water.
And there shouldn't be any boat above the water.
What?
Because the boat's heavier than the water. So how does that work, man?
And there they go bring up the heaviness. I never said anything about heaviness. We're talking about more dense and less dense. The less dense, yeah, I used to think that, you know, a boat was not less dense. For me, it used to be, as I said, with my first equations, my original equations. So, you know, if the mass of the water displaced is more than the mass of the boat, then, you know, the thing will float. If the mass of the water that's displaced is less than the mass of the boat, then it'll sink. That's how I originally came up to my equations. But then I spoke to conspiracy cats who told me that actually, because boats are mostly empty space, they are actually less dense than water, so they float. So there's one or two ways of looking at it, I suppose.
Because mass and weight are the same thing. Those are the equations.
It just fucking doesn't. See, if you take gravity out of the equation, density doesn't know what to do. Density is meaningless. Because density requires gravity to work.
Prove it.
I think.
You're doing a live video or recording a video. Why are you doing that?
I already said, you know, trying not to wake my kids up, but yeah.
Questions from people that soon. The fact that because of
You have to be at least within the Earth's gravitational field. Gravity affects a lot further. The reason why we have the Kármán line isn't where gravity ends. The Kármán line is where space begins. That's where a plane can no longer maintain flight. That's the Kármán line. It's not, space isn't where gravity ends.
I never said it was, did I?
Gravity goes Earth's gravity.
That's why they float, but yet the
Right.
International Space Station is falling because of gravity. So
Right. There's some gravity. There's some gravity. In order to be in orbit, you have to be at least within the Earth's gravitational field. Gravity affects a lot further. The reason why we have the Kármán line isn't where gravity ends. The Kármán line is where...
So another straw man, something that I never said, and nothing about the Kármán line, nothing about where space began and gravity ended or whatever.
Space begins. That's the Kármán line. It's not, space isn't where gravity ends. Gravity goes all the way to the moon, girl.
Apparently, yeah.
And further.
obviously
yeah.
gravity is affecting the International Space Station because they are falling, which means that they shouldn't even be floating. So, and in fact, I'll actually link a video where the one lady astronaut says from the International Space Station actually says that it's like 10% less on the International Space Station, the gravity, than it is on Earth.
Right. There's still gravity. It's just a lot less.
10% less.
There's gravity on the moon. It's just a lot less.
Prove it.
It's like they've been up there 20 years, so the amount of...
See, you believe that there's gravity on the moon because you believe what you're told. Have you been there and verified it for yourself? No, so therefore you just believe the footage and the, you know, the pictures and things that you've been shown. Do you know what I mean? The information that you've been told. Have you verified it for yourself? No, of course you haven't.
shouldn't be falling infinitely fast. See, this is what happens when people who don't know science try to science. When people don't know physics, try and physics.
Falling right now.
Okay, so obviously with the International Space Station, I originally thought, that they was accelerating round, being that they're meant to be, affected by gravity, and gravity is an acceleration. So therefore I thought they was accelerating, which would also explain why they was floating, as the floor, moves faster than what they were moving. Kind of like the plane, vomit coming, you know what I mean? But, yeah, apparently they're going at constant speed. So, yeah. I'm not entirely sure how that works as well, to be honest, because, you'd think that they'd have to be accelerating in order to, be weightless. I mean, if the plane fell at a constant speed instead of accelerating downwards, would they be weightless? I'll have to think about that some more.
Be tremendous, okay?
Goddamn program long enough to make a video.
Actually...
Oh, this is one day where it was all over my ass.
So basically, it was saying something about mumbling, and I do feel like I mumble a lot, to be honest. And I just found it kind of funny that the TV was telling me to stop mumbling.
Have I ever used an elevator before? When you go up, you feel heavier, and when you go down,
That's basically what it was about.
Yeah.
Still on the floor? No, so that to me says that the extent.
No, you don't feel it. Well, yeah, you feel it standing still on the floor. When you walk on the floor, your feet hit the floor. You feel pressure on the bottom of your feet. If you jump and then land, you're going to feel pressure on the bottom of your feet.
Well, obviously, I'm
If
sitting
you're
on the floor.
a fat person,
It's putting pressure on me. I'm putting pressure on you.
I weighed 250 pounds at one point. And my feet hurt all the time. My back hurt all the time. When I lost weight, got down to 140, my feet didn't hurt so much. I could walk further. My back didn't hurt because I didn't have all that fucking weight to haul around. So yeah, you feel it. Now, you won't feel like you're falling when you're standing on the fucking earth because you're not falling.
I don't even know if the is it moving.
Well, that's not what I says. Again, it's another straw man. I'm answering questions to people who say, in an elevator, you go up, you feel more weight, you go down, you feel less weight. And I was answering that question. I'm not talking about standing on the earth. We're talking about elevators, but, misrepresent me and misquote me and, straw man me again, why don't you?
Yeah, I'm that guy. So that says to me that the earth is stationary. Yeah, somebody says, wait.
This thing feels like it should weigh more than this thing. That's its feeling. That's the feeling it gets. Or it should weigh less. This should weigh more. That's the feeling it gets.
So now he's talking about the objects feeling things. I don't know. Another straw man, I guess.
Earthers don't agree on everything.
Because for me, I says...
Thing feels like...
So let's see what I says, actually.
Obviously, I've been told so many different things. You say
So weight is just...
Yeah, somebody says weight's just a feeling. This is the thing with gravity. I've been told so many different things. You say
So weight is just a feeling. So
yeah, that's what somebody told me, that weight is just a feeling.
This thing feels like it should weigh more than this thing.
So I guess he's not straw manning me. I'm guessing he's straw manning the person who told me that weight is just a feeling. No, I never said objects feel weight and objects feel anything. They're objects. But yeah.
That's its feeling. That's the feeling it gets.
That's what somebody
Or
told me
it should
gravity
weigh
was,
less.
a feeling.
This should weigh more. That's the feeling it gets.
Yeah. Laughing at your own Glober friends that tell me about gravity being just a feeling. I felt the exact same way, mate. Glad you're laughing at them too. Kind of weird, isn't it?
Earth Earthers don't agree on everything, but you globe Earthers don't even agree with gravity. We have heard.
Yeah, we do.
Oh, you was just laughing,
Oh,
mate.
most certainly.
Hold on a sec. You was just laughing about the objects feeling weight because gravity is a feeling. That's not what I'm saying. If you understood, I'm reading questions that commenters had gave to me, and commenters had told me different things about gravity, and one of those things was gravity is a feeling of weight. Gravity is a feeling. So you just laughed at them without realising, thinking that you're laughing at me. But really, you're laughing at your own globe of people who say that, because there was all globers that told me this stuff. So, you know. And then you go on to say that you agree. Who's just laughing at them? So clearly you don't agree, do you? Oh, my days. Like, seriously, these people are funny.
They do. Gravity is mass attracting mass as a result of a disruption in space-time and a warping of space-time.
Can you prove that? Or again, is that just something that, you know, you was told and you believe?
The bigger the mass, the more the warp.
Prove. Show me.
So, yes, we do agree on that.
And show me how warping space-time causes mass to attract mass. You know, that's like saying warping space-time causes magnets to attract magnets. No, doesn't work like that. Do you know what I mean? There's a mechanism behind it, and bendy space-time does not account for mass attracting mass. Can you prove that? Do you have any evidence of that? Can you verify that? Is there an experiment that you can do where you can unbend space-time to prove that it was the bending of space-time? And then that mass no longer attracts mass once you unbend the space-time? No, you can't, can you? So you can't really experiment with it to make sure that's the cause and that's the reason, can you? But yet you say it is, because that's what you learned.
Don't understand how it happens, why it happens, but we understand that's the reason.
We don't understand how or why it happens, but we understand that's the reason. What? So you don't understand how or why, but that's the reason. So you don't know how or why, but you know it's mass bending space-time which causes mass to attract mass. But you don't know how or why. That don't even make sense. Your how and why is because of mass bending space-time. Do you know what I mean? Like, why does mass attract mass? Because mass bends space-time. How does mass attract mass? Because mass bends space-time. That is your how and why. But then you go on and say that you don't know the how and why. You know why? Because it's BS, quite frankly. You know what I mean? It is BS. And you're just hilarious, to be honest, mate.
That it happens. Flat earthers can't even agree on what the fucking thing looks like at all.
True. Yeah, we can't agree on what it looks like. I agree with that. Probably the first thing I agree with you on. But at least we're trying to figure it out. At least we're not just, you know, having answers given to us and be like, okay, you got to agree with that because that's the answer. You kind of think, do you know what I mean? Like, that's the answer that somebody's gave me. That's the answer. So I'm not going to research it and look into it myself. That's the answer. That's what Google says. That's what scientists says. You know, so I'm not even going to research or try and bother doing experiments or anything else because, you know, that's just what they say. And I'm going to believe what they say, which I don't agree with. So for us doing our own research, you know, we don't always agree. But like I said, you don't agree on what gravity is either. Do you know what I mean? Mass attracting mass, bendy space-time, upwards acceleration, downwards acceleration. Make up your bloody minds.
I mean, you can't agree on that fucking one thing.
Sorry, can you agree what the Earth looks like? And please just do not say a sphere. Show me an image. All globers, show me an image of what the globe looks like. Guarantee you all give me different images, different colours, different fucking sizes, different everything. Do you know what I mean? So you can't even agree on what the Earth looks like yourself. Do you know what I mean? Just use NASA images, which all look different anyway.
The base of your entire premise. You can't agree on it.
And you can't agree on gravity. You know what I mean? Like, seriously? You don't agree on gravity. Oh, space-time's bending down. Oh, the Earth's accelerating upwards through space-time. And but we're not actually moving. Oh, but it's mass attracting mass. And you know, it's bendy space-time. And now there's gravitons. And now there's dark matter. And you know what I mean? There's this and there's that. And nothing's ever been proven, but we'll believe it anyway. Do you know what I mean? So annoying.
Seems to me that wouldn't be repeatable. That makes it
Oh, but bendy space-time and unbending space-time is repeatable. Oh my days, the audacity of this person.
not repeatable. That makes it invalid as science.
Okay, bending space-time is not repeatable. That makes it invalid in science. Go and bend some space-time for me. You can't do it, then it makes it invalid in science. I'm glad you agree.
So many different explanations for gravity.
What is so fucking hard to understand about this, girl? Seriously.
Those are the ones at the top.
About what?
Created by mass attracting.
Acceleration. I think there's a few more.
Right, it's all those things. Gravity is an acceleration created by mass attracting mass. What is so fucking hard to understand about this, girl? Seriously.
How does mass attract mass? Bendy space-time? Show me bendy space-time, unbend space-time. What did you just say? If you can't repeat it, it's invalid yet? So, your space-time's invalid. Can you repeat it? Can you experiment with it? Can you show me you bending space-time? Can you show me how that has an effect? No, so that makes it invalid then, doesn't it?
Those are the ones off the top of my head.
No. It just means you don't understand. So maybe you should go try and understand or learn how to understand before you take on a subject like this.
Or maybe I am trying to understand and I'm getting many different answers with many contradictions, many not agreeing and many telling me different things. You know? Maybe if people didn't, tell me things that they think are right and then they turn out to be wrong, maybe I'd actually know. But, the fact that people think that they're right but then contradict somebody else and then contradict somebody else and then contradict a scientist and then contradict whatever. Do you know what I mean? Like you saying, if you can't repeat an experiment or whatever, it's invalid. Well, if you can't fucking unbend space-time or bend space-time, then it's invalid, isn't it? Simple.
After all these centuries, you would think that they would know by now. So obviously, maybe it's not correct. Don't have weight, but it means that it's what you physically feel. So in that case, it goes better. So
anyway, this goes on for another 11 minutes, and I'm not going to get struck because of this. But we'll go to the next one.
So then he just goes on about like the quantum mechanic books, and then he just does the coin videos, which he ends up, skipping the good parts when he gets to the good parts. And then obviously
we've got to tell you that
the
level means horizontal. Sorry. What's this?
So according to FTFE, I'm a liar and attention seeker because I told him that in school I learned that level is horizontal.
Which I did.
Right. No, you didn't.
Oh my days. How can you tell me what I did and did not know at school or what I did and did not learn at school? Was you at my school? No. So don't tell me what I did and did not learn at my school. Do you know what I mean? This is what annoys me the most. Telling me that I'm lying, telling me that's not where I learned. That is what I learned. Whether you like it or not, that is where I learned. So call me a liar all you want, which absolutely annoys me because I actually can't stand liars. Do you know what I mean? But to actually call me a liar when I'm actually telling the truth actually really pees me off because, do you know what I mean? I did learn level was horizontal at school. And if you can't understand that and you can't, think that the best you've got is you rely. You know what I mean? You rely or whatever. Do you know what I mean? It's like, okay, well, you don't learn something else at school, so therefore you're a liar. Do you know what I mean? No, I can't tell you what you learned at school and what you didn't learn at school. I can't tell you what you've been through in your life and what you haven't been through in your life. So therefore I cannot call you a liar, can I? So don't turn around and call me a liar when I did 100 million% learn that level was horizontal. You ask any normal person out there, you go outside and you ask any normal person out there whether or not, level is horizontal. They will tell you level is horizontal. No one, absolutely no normal person will tell you that level is conforming to the shape of the earth. In fact, you know what? I'll even do a challenge with all people. Go outside, go to random people, go and ask them what level means. See how many tells you it's conforming to the shape of the earth or conforming to the curvature of the earth or whatever. Guarantee you 99% would tell you level is horizontal.
No school is going to tell you that level means horizontal.
Well, they did.
Sorry. You can find a dictionary if you want, but level is not horizontal.
You can find a dictionary if you want, but I'll still disagree with the dictionary and you because I'm right, basically, is what you're saying. Honestly.
Look up horizontal. Look up the adjective for horizontal or level. Look that up.
For horizontal or level. So you're admitting that horizontal and level are the same. Look up the adjective for horizontal or level. So are you trying to say that horizontal and level are the same, even though you're trying to tell me a liar saying that they're not? Make up your mind.
Apparently that makes me a liar and an attention seeker. So this is my dictionary, thesaurus from school. It's the Oxford Paperback Dictionary and
I'll be
Thesaurus.
right back.
The world's most trusted line or plane. 2. Height or value reached.
So yeah.
3.
Basically, we go through all this. You know, you can watch it if you want to watch it. It's on my original channel, or you can go watch Shawn's video and watch, you know, the majority of things the ones that he didn't skip anyway. He didn't skip this one, I don't believe. But yeah, not in there any way, shape or form did it say curve. It did, however, say level is horizontal. So, yeah. Oh, and then he tries to look up level, and then he can't find the bloody thing that he's looking for. Fascinating. You know what I mean? Looking for his biased search that says
I'm already
that
showing
it's...
this, so.
Yeah, looking for his biased search which says that it's conforming to the curvature of the Earth, but yet he can't find it now. You know why? Because there's like probably one thing that says that, whereas the rest tells you it's horizontal. Let's see what this says. Oh, I probably should have actually switched my screen around. Sorry about that. A horizontal plane or line with respect to the distance above or below a given point. Oh, so level is a horizontal plane or line. Adjective, having a flat, even surface with no slopes or bumps. I'm guessing that bit says. At the same height as someone or something else. So, yeah, there's your adjective level. Having a flat and even surface. You've looked it up for yourself for me. And you've proved me right. Level, adjective, having a flat and even surface. Is that conforming to the curvature of Earth? Didn't think so. But carry on spreading your lies. Calling me a liar. You've got it right there in front of your face. The adjective that you wanted. Do you know what I mean? You've looked it up yourself. Non-biased. You've tried to look up, but you're trying to be biased. It tells you right there, adjective in front of your face, that it's level and even. Do you know what I mean? And whatever it says, do you know what I mean? Flat and even or whatever. Do you know what I mean? And now he's trying to look for the one that confirms what he's trying to say.
Before. Having a hard time
but even though
finding
you
shit
confirm
today.
what I'm saying with what you're looking up right now. But I'm a liar. Yeah, okay, I'll do it. Whatever.
Anyway.
1. Even, flat.
But yeah, even, flat, exactly. Right. Then he tries to say at some point in this that I looked for a dictionary that actually confirmed what I was saying out of all the dictionaries. No, that's just a dictionary that, you know, I've had since basically school. I think it was my brother's, I believe, actually. And I've had it since, since, you know, at school. It was either mine or my brother's. We both had the same one from the same school. There's a few years difference between us, but we both got the same dictionary. I don't know whether it's mine or my brother's, but yeah. But yeah, basically, we've had the same dictionary from school. And no, I haven't just randomly picked out a dictionary. That's just one that I have. I don't think I have like 25 dictionaries lying around, like seriously. I had one dictionary and I've kept it. Simple as that. But carry on trying to be biased and carry on trying to say that level is not even and flat, even though you've just really pretty much proved it on your own screen, mate.
Neck and neck, the same.
So yeah, then he just goes through some more, you know, videos and talking and whatever. But I'm coming up to on an hour now, so I might revisit this at some point. But yeah, it just really annoys me when people, you know, assume things and do all this crap and that, and you know, then he proves my point for me by showing that level is actually even and, you know, flat and whatever. Great job, Shawn. Great job. Yeah. Speak to you all again soon. Take care and stay safe.